Hey, geometry students, this is Mr. Shack, and this is your Unit 8 test review video. Seems a little longer than usual. I don't think it really is. I think you honestly just have a little bit more space to work. There's only one on this back sheet, but I guess two front and back pieces of paper. But when we're talking question number-wise, not too much more. But I will be trying to go fast to make sure that I can get this in before my go time gets here. So, with that being said, please remember it's a video. You need to be using this. Pause it. I'm going to write this because I've noticed some people watch it without volume, which is not helpful. So please turn up that volume. Because if you're watching this without volume, well, then you might as well just pull up the answer key and copy that down. And that's not going to do anything for you. That's not going to prepare you for the test. A lot of you need to do really well on this test to help your final grade in the class. Some of you need it to pass the class, stuff like that. So please make sure you're taking your time to fully understand each of these questions, know how to do them, try to do them on your own, hit that play button when you're stuck, and then pause once you're rolling again, and then hit the play button to check your answers, stuff like that. That's how you should be using this video. Okay, so that's your reminder. Make sure you're pausing, rewinding, using this video to your advantage, not just listening to it through and copying everything down. That is not going to teach you what you need. Okay, so starting off here, we have a secant tangent in a circle, and the rule there is, and again, you can use your formula sheet, so you could say, oh, well, what looks like that? And that is going to be this guy here, and what that says is the whole length times the external length equals ct squared. Well, that's our tangent length squared. So we're going to call this x. That's what we're trying to find, dc, and we're saying whole length here. Okay, well, the whole length is 17 plus 4, which is 21. Okay, so that whole length times the external length of that secant equals our tangent length squared. That's what the formula says. So from there, 21 times 4 is 84. 84 equals x squared. You're going to have to take the square root of both sides then. Square root of 84 will give you x. And if you want to do that as a decimal, that's about 9.2. If you left it as the square root of 84, I would also accept that. Okay. Now, going on to this next one, you have this pictures given to you originally on the original test. There was no picture at all. You had to draw all of this. Okay, but now you just really have to label the points. So it says points N and M lie in a circle, and point P is outside the circle. So that makes this point P. Okay, and then notice it says NP intersects the circle at point K. So let's call this N. And then if it intersects, so NP is this, right? If it intersects the circle at point K, then this would have to be K. And then it goes on and says MP intersects the circle at point L. Okay, so that makes this have to be M, because then we have MP here, intersects the circle at point L. There we go. Now we are able to label this. It says NP is 110 yards. Well, that's this whole length here is 110. Okay, and NK is 79. Well, NK is just this portion. MP, 83 yards. That's, again, this whole length here. And that is 83, like I said. Okay, from there, what is the length of LP? So we're trying to find this. I will call this X. Okay, and again, you're looking at your formula sheet now, and you're looking for two secants that intersect outside of the circle, and that is this guy down here. And you will see, again, it's whole length times external length equals whole length of this guy times external length of that one also. Okay, so that's what you're using, and you need to make sure that you know which formula to use and how to use this formula sheet. So this review should be good practice of that also. Okay, and if it's whole length times external length, well, then we need to find this external length, which we can find real quick by doing 110 minus 79, right? Because that'll give us this length. Well, 110 minus 79 is 31, so that makes this 31. Now we have enough information to go ahead and say, okay, whole length, that's 110, times external length of that one, which is 31. Again, that equals whole length of this secant, which is 83, times external length of this secant, which is just x. Okay, from there, let's go and do the math. 110 times 31, do it in the calculator, it's 3410. equals, well, this is just 83x. How do we get x alone? We have to divide by 83, and we get x equals 41.1. Okay. All right, moving on. We have quadrilateral JKLM inscribed in circle S. The measure of angle L is 54 degrees. What is the measure of angle J? Okay, well, you could draw this out, draw an inscribed quadrilateral. So you got this, and then you got a quadrilateral inscribed in here, so you could draw something like this. And you would realize that these 2 points, J and L, are across from each other. Otherwise, you could say, oh, J and L, those are not 2 letters that are right next to each other, so those are opposite angles, right? If we drew this out, we would have J, K, L, M. J and L are opposite angles across from each other. And you need to know that opposite angles add up to 180, okay? So in other words, 180 minus 54 would give us angle J. Okay, and you just have to know, and that is on your formula sheet also. That's this guy right here. It says A plus C, opposite angles, D plus B, opposite angles. Those add up to 180. Okay, so 180 minus 54 will give you your solution there, and that is 126 degrees. Okay, moving on, if you have a circle with a center of -2, 9, so we're now trying to put this in an equation of a circle, and this is always going to look like this. Okay, this is also the very top formula on your formula sheet. And if it's a radius of 7, well, that's going to equal 7 squared. So we got 49, because you always take the square root of this guy to find the radius. That's why we did 7 squared to get what's going to go there. And now we're saying, okay, if we see a -2, well, that's going to appear as a +2 in our equation. If we see a +9, that's going to appear as a -9 in our equation. So that is our circle. And then it says, state if it passes through the point 5, 9. Well, in order to find that out, we have to plug this 5 in for x, this y in for 9. And again, I know I'm going fast, but you should be doing this on your own and then using this to check. Or if you're using it to get unstuck, then pause. Or if something's not clicking what I'm saying, rewind, listen to it again. Slow down the video. I think that's even an option. Okay, so if this is our x, we're plugging that in for x. We have 5 plus 2 squared plus, and then we're plugging in the 9 for y. So 9 minus 9 squared equals 49. Okay, well, 5 plus 2 is 7, so we get 7 squared, plus 9 minus 9 is 0, so 0 squared equals 49. Okay, and we want to see if we are left with a true statement, then yes, it passes through that point. If we're left with like 48 equals 49, well, no, 48 does not equal 49, so it would be a no. But 7 squared is 49. 0 squared is 0, so we are ending up with 49 equals 49. That is true, so we can say yes, it passes through that point. Moving on. I think you guys can tell I've had a good amount of coffee this morning, and I am feeling it right now, so we are racing through this, plus I have to in order to get this done before my go time kiddos get here. So the hour hand of a circular clock sweeps an arc as it moves from 10:30 to 2:30 a.m. Okay, the same night. Well, think about this. How many hours are passing? If we're going 10:30 to 11:30, that's 1 hour, to 12:30, to 1:30, to 2:30. Okay, that is 4 hours. 4 hours, and there are 12 hours in a full rotation of a clock. So I say 4 hours out of the 12 hours in a clock. Okay, well, this can be reduced to 1/3. Okay, and we're trying to figure out, well, what is the measure of the arc in degrees? So what is the angle measure of that arc that the hour hand sweeps? Okay, and in order to do that, then we're saying, okay, well, that's a third of a rotation. It's going a third of the clock. But if we're trying to figure out in degrees, well, then we have to multiply it by how many degrees are in a circle, and that's 360. So we really just have to do a third times 360, which ends up being 360, because when you multiply fractions, it's 1 times 360 over 3 times 1. So this ends up being 360 divided by 3. That'll give you your answer. When you do that, you should get 120 degrees, which is your answer. Moving on to number 6. Okay, number 6, we have arc AB and CD are congruent arcs, and then they're talking about if the length of AB, this is now a chord, is 3x plus 13, and the length of CD is 5x minus 5, what is the value of x? Okay, well, congruent arcs are created by congruent chords, so these have to be congruent, meaning we set them equal to each other. 3x plus 13 equals 5x minus 5. Okay, figure out how to solve for x. Now you got to get all your x's to one side and numbers to the other. So I'm subtracting 3x from both sides. I'm going to add 5 to both sides. That makes these cancel. 13 plus 5 is 18 equals 5x minus 3x. That is 2x. Negative 5 plus 5, those cancel. Okay, again, I know I'm going super speed here, so pause, rewind, do what you got to do to make sure you're understanding these problems. You need to understand these problems. You would divide by 2 to get x alone. 18 divided by 2 is 9. That is your answer there. Okay, moving on to tangents RP and SP intersect at point P outside a circle. Okay, this is a tough one. Got to know what these words mean. Okay, so we have a circle. Two tangents intersect at P, which is outside the circle. Let's call that P. Tangent lines are lines that touch the circle at exactly one spot only. So there are my tangent lines, and it said it's RP and SP. So I will call this R, because now we have RP, and then this will have to be S. So this is SP. Okay, and now it says RS, so that's this arc here, is 60 degrees. So this is 60 degrees here. What is the measure of RPS? That's an angle. That is this angle measure that we're looking for. Okay, and this is where you have to get a little bit creative and say, well, how can I find this? Well, now you have to draw in a central angle. Okay, and mine is, please know this is not drawn to scale because this angle is going to look like 180, but this is really not drawn to scale. Central angle always equals the arc length here, so the central angle has to be 60 degrees also. Okay, and then we know what about opposite angles here? Well, opposite angles are you almost caught me. Opposite angles add up to 180. Okay, so you could think, okay, well then 180 minus 60 has to give us angle P. It will. That is 120 degrees. That is your answer. Okay, opposite angles like this have to add up to 180. Moving on, okay, we have a circle with radius of 12 centimeters. It has a sector with area 26.39. Okay, we're talking sector area, so you would go to the very bottom two formulas on your formula sheet that look like this, okay? And you are saying, okay, with a radius of 12 centimeters, okay, so maybe draw it if it helps you, or you don't have to, but sector area, okay, is 26.39. Okay, so I'm using my sector area formula. This replaces the A. That equals x over 360. Okay, we don't know what x is right now, so we're just writing it as x over 360. Okay, times pi r squared. Okay, pi, we know our radius is 12. 12 squared, I guess we'll just write it as that for now. Okay, now let's simplify this out a little bit. We want to get rid of this denominator of 360. So I'm going to multiply both sides by 360. That will get that to cancel. Okay. And what I do to one side, I got to do to the other. Okay. Multiply 360 times 26.39 in your calculator. You should get 9500.4. That equals, okay, pi times 12 squared. Well, 12 squared is 144. So I'm writing this as 144 pi. Okay. Oops, and I forgot the x. We have x here still. Okay. Now, if we're going to solve for x, this is being multiplied by x, so we need to do the opposite of that to get x alone. So we are going to divide by 144 pi. Here we go doing that. Divide both sides by 144 pi. Okay. And if you are doing it in your calculator like that, that'll get x alone. 9500.4 divided by, and then you would have to put in parentheses, I'll show you what I'm talking about here, 9500.4 divided by, if you're doing this all in one step, you would have to do parentheses 144 pi, okay? Because otherwise, your calculator won't know exactly what you mean. It'll just do it divided by 144, and then it'll like do an enter within the system and then multiply it by pi. So you need to enter it in like this if you want to get the correct answer. And it's 21.0004, so we're just going to call it 21 when we round. Okay, so that's x though, and it's asking for the length of the sector. Okay, so now we go to arc length formula, which is the one to the left of the one we just used, and it says sector equals, okay, x over 360. Well, we just found x to be 21, so we got 21 over 360 times 2 pi r. Okay, well, r is 12. So you could go ahead and now do this however you want. 21 divided by 360. Maybe just do this all in your calculator. 21 divided by 360. Enter. Okay. Now times 2. Enter. Okay. Times pi. So times pi. Enter. And then lastly times 12. So I do times 12. Enter. That's going to be our answer. That rounds to 40. Oops, not 40. That rounds to 4.4. Okay, and that is our sector length, 4.4, and saying centimeters, so we can say centimeters here. Okay, so that was a bit of a tricky one. Maybe not really, actually. You're just using formulas. Number 9 we could call maybe a tricky one because that is when we're dealing with the equation of a circle. Okay, so what we need to start off is get all of our single numbers to the other side of the equation. Okay, so I'm subtracting 142 from both sides. That will get it over there. And now let's write this out, getting our x's together and our y's together. Okay, so we have x squared plus 6x plus, remember, you got to leave a blank. Okay, now we go to our y's, plus y squared minus 24y, again, have to leave a blank, equals, well, we subtracted 142 from both sides, so we are left with negative 142 over here. Okay, now again, if we're being asked what is the radius of the circle, well, we need to put this into this type of form. Okay, where we have x plus or minus something, y plus or minus something squared, okay, equals, then whatever it's equal to is what we'll be able to take the square root of to find the radius. Now from there, you're taking this value, our b value, dividing it by 2. That's 3. That goes there. 3 squared goes here. That's 9. And if we're just adding a 9 to the left, we got to remember to add it to the right. So I add 9 over here also. Same thing here. Divide this number, our b value, by 2. Negative 24 divided by 2. It's negative 12. Okay, again, it's always going to be divide the number that is being multiplied by the single variable by 2 to get these two numbers. Okay, and then you have to square it to get this blank. Negative 12 squared is 144. Okay, and if we're adding 144 to this side, we got to do it to this side also. Now, negative 142 plus 144, that's positive 2. 2 plus 9 is 11. We're left here. It's asking what is the radius? Well, you always take the square root of this number to get your radius. So our radius is square root of 11. Okay, moving on because I do not want to run out of time. It is a little bit of a lengthier review, but we are getting there. Okay, this one will go really fast because if we're writing an equation of a circle, again, it should look like this. And this equation of a circle is on the top of your formula sheet. The very top, very first one on the front page of your formula sheet gives you equation of a circle. You just need to know, okay, if this is my x value and negative 63, that means I have an x plus 63. Okay, if I see a positive 16 for my y value, that means I have a y minus 16. It's always going to be the opposite of how it looks. Okay, and then a radius of 13. Well, remember, you take the square root of whatever this number is to find your radius. So if we're going from radius to whatever goes here in the equal sign, we have to do 13 squared. That is 169. So that is what we are putting here. Okay, so this is our equation of that circle they are describing. Okay, this next one may look a little tricky, but if you really just think about what's going on here, it's not. The math part is not. We just got to figure out what are they asking. Okay, it says each rider stands 20 feet from the center. Okay, and we're talking about an amusement park ride. This is a circle unit, so you can expect it's circular, which it says here. So if it's 20 feet from the center, everyone's 20 feet from the center, that means your radius is 20. Okay, in the first 2 seconds of the ride, the frame rotates 49 degrees. Okay, that's got to be important. Through what distance does a rider move in the first 2 seconds? That's really talking about, we're talking distance around a circle. That's going to be arc length. Okay, so you go to that arc length formula, which is the second to last formula right here on your formula sheet. Okay, and you are filling in what you know. We know that they are going 49 degrees. So we are saying, okay, S is going to equal 49 over 360 times 2 pi r. Okay, well, 2 times 20 is 40, so I can just say times 40 pi. Okay, just using that formula. And from here, this is an easy peasy equation to solve. 49 divided by 360. Maybe we'll just go to the calculator, right? 49 divided by 360. Hit that enter button. Okay, now without hitting anything else, we go times 40. Hit that enter button again. Times pi. That'll give you your answer of 17.1. We are talking arc length, so we say 17.1 feet is how far they traveled in just 2 seconds. Okay. Now, moving on to 13. These are two very separate questions here because one is talking about an angle measure, one is talking about a segment length. Okay. So you're going to use two different formulas on the formula sheet. Okay. Starting off, if we're talking about segment length x, okay, this is the one dealing with segment length. So we should be using this one. Okay, and what that says is piece of cord times other piece of cord equals piece of cord times other piece of that cord. Okay, so in other words, 15 times 3 has to equal 5 times x. That's all you're doing there, and now you solve this out. 15 times 3 is 45. That equals 5x. How do you get x alone? You divide both sides by 5. What is 45 divided by 5? That is 9, so x is 9. Nice and easy to find x there. And now y, like I said, completely different. You're using a different formula because now all of a sudden we're talking about degrees and angle measures and arc measures. So with that, you're using, okay, this one. Here we have chords intersecting again. This is talking about angles. So you are going to use that formula now. And what it says is the measure of arc AC plus the measure of arc DB. Well, really, that's like saying the two arcs you have. So 104 plus 68 divided by 2 is going to give us these angles. Okay, so let's do that. 104 plus 68, scoot this up a little bit, divided by 2. Okay, well, what exactly is that? That is 104 plus 68 divided by 2. Let's do it real quick. Enter, divided by 2. That's 86. That means this is 86 degrees here. This would be 86 degrees here also. But it's asking for this angle. We're asking about angle Y. Well, those form a straight line, so you could do, well, what does a straight line add up to? 180 degrees. So we're saying 180. 86 of it is being used here, so 180 minus 86 is going to give us Y. Well, 180 minus 86, that's 94. So that is Y, 94 degrees. Okay, moving on to our last page here. Thinking I will not be running out of time, it looks like, hopefully, so that is great. Okay, and it looks intimidating, right? There's a good amount of words, 2 parts, but again, if you know what they're asking, it's not hard. Okay, so the surface area of the sign is covered in LED lights, and the curved part of the sign is a fluorescent light to represent the crust. Okay, if it's the crust, it's probably the outside. That could be important. Each straight edge of the sign measures 10 feet. Okay, this, I don't like how this is worded really. It's worded better on your test. The one that is sort of similar to this on your test is worded better. I will tell you that for sure. But what this is getting at is that your radius is 10. Okay, and your central angle measures 45 degrees. Okay, and we're talking what is the area of the sign that is covered in LED lights to the nearest tenth? Okay, well, it's 45 out of 360. You are using sector area, okay, which again, you are back to these bottom two on your formula sheet on the back side. You're using sector area, and what that equals is, got area equals your angle measure, which is 45, over 360 times pi r squared. Well, our r is 10, so we can really say times pi 10 squared, which is 100, right? So just like that, and now you can go to the calculator. So I'm doing 45 divided by 360, enter, okay, times pi, enter, times 100. That will give me my sector area, which is 39.3 when we round. Okay, 39.3 square feet is my area. Now here it's asking what's the length of the fluorescent light. Well, remember the fluorescent light is representing the crust. That means that's the outside. So this is now talking about arc length, okay? And that arc length, again, you are now using the formula here, and it's angle, which is 45 over 360, okay, times 2 pi r. Well, if r is 10, 2 times 10 is 20, so we can say times 20 pi. Okay, because the order you do multiplication in doesn't matter, right? So if, what I'm really doing is 2r pi, which is totally fine. 2 times r is 20 times pi. And again, we're going to our calculator. 45 divided by 360, enter. Okay, times 20, enter, times pi will give us the answer. 7.85. Once rounded to the nearest tenths, that rounds up to 7.9. Okay, that is your review video for Unit 8. Like I said, I hope you had the volume up the whole time. I hope you used this video to your advantage and trying to do it on your own, using it when you're stuck, stuff like that. If not, you need to grab a new review and try doing it that way this time. And there's no shame in grabbing a second review. Lots of kids have asked for a second review so they can do their own strategy. All you got to do is ask. All right, I'll catch you all later.